Okay, so in the next question, we have to find derivative of y is equal to Euler negative x cube plus 2x square plus 1. Now, first of all, these two terms are being multiplied. Okay, so Euler negative x is being multiplied by the x cube plus 2x square plus 1. So let me just rewrite this function right over here. Euler negative x cube plus 2x square plus 1. Okay, now the derivative of Euler having a function is Euler fx multiplied by the derivative of the function, and these two terms are being multiplied, so we can use the product theorem which we have just used in the previous question. So let's begin. Let's just apply the differentials on both sides of the equation. D by dx Euler negative x multiplied by x cube plus 2x square plus 1. So this thing right over here will be my fx, the first function, and this thing right over here will be my gx, the second function. Okay, the second function as it is x cube plus 2x square plus 1, then the derivative of the first function Euler negative x plus the first function as it is, derivative of the second function. So x cube plus 2x square plus 1. Now over here, first of all, we will write Euler negative x as it is, and then the derivative of the function, or the exponent you can say. So in the exponent we have negative x, so we have to take the derivative of negative x plus Euler negative x. Over here the terms are being added, so the derivative will be distributed to all of these terms. So we have d by dx x cube plus d by dx 2x square plus d by dx 1. So we have x cube plus 2x square plus 1 Euler negative x. Okay, so over here we have negative and the x will be cancelled, so we are left with negative 1 plus Euler negative x, then the derivative of x cube will be actually the power rule will be obeyed. Okay, so the power rule says that the power will be as it is, then the function and the power minus 1, so 3 minus 1 is actually 2, plus over here 2 is a constant, so it would be separated, then the derivative of x square d by dx x square plus the derivative of any constant is actually equal to 0. X cube plus 2x square plus 1, we have Euler negative x negative 1 plus Euler negative x 3x square plus 2, the power will be separated, the function, then the power minus 1, 2 minus 1 is actually 1. X cube plus 2x square plus 1, Euler negative x, negative 1. Euler negative x, we can multiply this 2 right over here, so we have 3x square plus 4x. And now in this term, we can separate this negative sign, and also this Euler negative x can be done at the first place, so we can write Euler negative x cube plus 2x square plus 1. Okay, so these terms are actually being multiplied, so we can rewrite them in any way. 3x square plus 4x. Okay, so we can see that the Euler negative x is common right over here, and over here we also have Euler negative x, so these terms can be taken out as common. Let's just take this term as common, Euler negative x, and over here we are left with the negative sign will actually be left. Okay, because we cannot take it out as common because the negative sign is not present on both of these terms, so the negative sign will be left, and over here we have this term x cube plus 2x square plus 1. If we take out Euler negative x common from this term, we are left with 3x square plus 4x. If we simplify further, this negative sign will be multiplied, so we have negative x cube, negative 2x square, negative 1 plus 3x square plus 4x, and then Euler negative x. So let's just simplify these things. So 3x square minus 2x square is actually x square, but first of all, this negative x cube cannot be cancelled, so it will be left as it is, negative x cube plus x square. Negative 1 can also not be simplified, and 4x cannot be simplified, so we are left with 4x minus 1. So this is the final derivative of this function.